is problem number 11 on page 195 of your textbook, and it's very scary looking. The bad thing about things that are scary looking is that they intimidate you. The good thing is that after this class, you should never be intimidated by anything. This is a really, really, really easy problem. So we're just going to start in the middle and start tearing things apart. Now, you remember the resistance total, when we have the same resistance resistors, is the resistance divided by the number of them, right? And it's really simple when it's two of them, right? For instance, look at these two right here. We can make an equivalent resistor out of that that's 25 ohms, right? 250s in parallel, that's 25. Now we're going to look at this whole thing right here, which is this whole left-hand branch. It comes up to this point, and 25 plus 5 is 30 ohms for that whole branch from this point and that point all the way down to this point, right? 30 ohms. What's on the right side? 60 and 60 in parallel. We have an equivalent resistor of 30 ohms. So this side plus this side, 30 and 30, is 15 ohms in parallel. So the resistance between this point right here and this point right here is 15 ohms. Now, we've got one resistor that's in series before we get to the bottom of the circuit. So 15 and 15, so this total branch on the far right is a 30 ohm resistance, right? 30 ohm resistance. And it's all in parallel with this 30 ohm resistance, so our total resistance to the right of this point right here is 15 ohms. Everybody see that? And then we have this one right here that's in series with everything, 15 plus 10. So RT is 15 plus 10, or 25 ohms. See how easy that was? Don't let the looks intimidate you. You're smarter than you think. So when you stop and go, wait a minute, that parallel branch becomes this, that one becomes that. Oh, add that 5 to that, that's 30, that's 30. Hey, that whole thing is only 15. Then in series with 15, it's 30 for the whole thing. That whole thing is in parallel with this 30, makes 15 for the whole thing. And this is in series with everything. Add that to it. We're done. That was too easy, wasn't it? All right, another problem that's intimidating, but it's not really hard at all, is number 10. Okay? And number 10 looks really scary. But you know what we're going to do? We're going to start putting things together. And so if we take these two right here, we know that we've got a 2 and a 6 in parallel, right? What's my equivalent resistance if I've got 2 and 6 in parallel? Thank you. So let's take this thing out and put in an equivalent resistor. We don't even know what number it is, but we know it's, let's call it 2, 3. Okay? Uh-oh. I made it really simple. Oh, no, because we got 1.5 and 1.5 in series, right? Oh, shoot. Let's take this whole thing out and make an equivalent resistor. Everybody okay with that? 1.5 is 3 ohms. We're going to say we have one equivalent resistor of 3 ohms. Is that okay with everybody? Okay, Soraya? All right. Now, so I've got 3 ohms and 6 ohms in parallel, right? Ooh, that's hard. Let's put 3 and 6 in parallel. What do we have? How many? 2. I like that number. Nice, simple number. Now, what we're going to do, we're going to take all this stuff out, and we're going to say we have an equivalent resistor of 2 ohms. Well, wait a minute. We've got 10 ohms in series with everything, right? So now everything between here and here, we're going to take all that stuff out, and we're going to make 12 ohms, right? Everybody okay with that so far? Now let's go over here to the right side. Now you can see, I think, that these three are in parallel all by themselves, right? So everybody got your calculator out. Hit clear twice. 4x minus 1 plus 4x minus 1 plus 2x minus 1 is equal to, x minus 1 is equal to, and we get 1. I like that. Okay, we're going to take all this out. We're going to say we have an equivalent resistor here of 1 ohm. Everybody okay with that? If you look at my top part, I got a series 1 and I got a 14. What am I going to do? I'm taking them out. I'm putting in a single series equivalent resistor of 15 ohms. Everybody okay with that? Now I've got one that's in 15 for that whole top branch, and I've got 10 in parallel down on the bottom, so I'm going to do a parallel resistance again. I got 15 x minus 1 plus 10 x minus 1 is equal to, x minus 1 is equal to 6. So now we're going to get rid of all that crap, pardon the expression, because that whole thing was 6 ohms. Everybody agree with that? Okay, I've got a series and a series. Now I'm going to simplify this down to one final total resistance, and it's 6 plus 12, 18 ohms is my totals. Too fast? Watch it again. All right.